we go.
Got it.
Okay. I will go ahead and share the minutes. No one has any other objections. It's 10:26. Okay. I already made it larger, because I know that's usually the first complaint. I figured today we'd start out with Grape 2 updates, but we do have a steadily growing mass of other business, so let's, I don't know, try to keep it within the next half hour or so if we can. John, did you have anything to add on the Grape 2?
Making progress. I did myself. I have put out 4 new sets of bids for the first board since I went ahead and just got all the parts, because some of the contractors wanted the parts supplied, so it wasn't that much to buy a bunch of resistors and capacitors. So I now have a complete set of parts for the the Grape 2 RF deck, and posted out 4 sets of bids yesterday. And I've got a couple I haven't looked at yet that came back this morning. In reference to a conversation we had last week about doing digital RF on the Grape 2, it will not happen for 2 reasons. One, we don't have the processor bandwidth to pull off the 3 extra channels of doing the FFTs on the fly. And the second kind of small problem is this digital RF will not run on the Raspbian OS. Minor detail. But in thinking about it, there are 2 other issues with running digital RF. And the biggest one that I'm worried about is, since we're only doing 10 hertz or plus or minus 5 hertz around the 1 kilohertz carrier, we cannot distinguish between WWV and WWVH. And that's a real issue out on the West Coast. So that I see as a major impediment unless we widen the bandwidth up to at least 1200 hertz, or actually it's going to have to, 1200 hertz around the carrier to be able to detect the 1 second ticks and the 500, 600 hertz flip-flop. Other than that, let's see. Oh, the other thing is using digital RF. The digital RF uses the OS timestamp to sync. And even if you sync the processor up to be a Stratum 1 clock sync off of the GPS satellite constellation, the Stratum reference is to where it's getting its clock source from. It's not how accurate it is. And since you have 2 non-deterministic loops going on for determining the time on the Raspbian OS, 1 is the operating system, and 2 is the non-deterministic. If you're using you're using it over Ethernet, which is also non-deterministic. And you add the third thing, actually, which is the PID loop that the NTB daemon is trying to maintain to increase its accuracy. It's still going to be in probably at best 10 to 100 microseconds in terms of accuracy to absolute UTC. And that may not matter for this experiment, but the Grape 2 is going to be looking like now it's going to either be within 50 to 100 or 62 to 125 nanoseconds of the actual 1 PPS coming from Boulder. So just putting it out there for future reference. Like I said,
John,
yes.
Maybe would you like to talk about this more later, because some of the things you're saying about digital RF are not true.
Okay.
And I think would you like to talk about, and again, digital RF isn't an absolute requirement, but I can tell you what the absolute requirements are. When would you like to talk about this? I also think this is an extremely important issue.
Yeah, it is.
If I can weigh in, though, I do think if we can generate the DRF, because we have to keep the raw files anyway, we want to keep the raw files, and we're going to generate the raw files. So if we can put DRF and do all of the same plots, if it helps.
The other thing is also recorded 44 hours live with the Grape 2 of WWE 5, 10, and 15. I'm going to get those files to Rachel for actual real-time processing.
Yes.
I
Actually-
think okay. Oh, hey, Rachel and John, would it be okay if we spend a few minutes on this issue?
Yes.
Yes.
Okay. So first thing I want to let's see. So at the a couple of things that you said about the digital RF that are not quite true. In terms of digital RF is not limited to 10 hertz. That's just what's implemented right now on the
Correct. That's what I'm talking about. I
Right.
know it can do the full bandwidth,
Okay.
but that gets us back to the problem we have with the Grape data. It's huge. Like 10 or 15 gigabytes a day.
Okay.
That's the problem.
So DRF is not limited to 10 hertz. DRF does not require you to do FFTs.
Well, whatever the processing it is doing to create the 10 hertz bandwidth, those 3 channels running continuously with what's going on with the Grape or the Grape 2 now, it's kind of over. We don't have the bandwidth to do it.
I'm still not sure that that's true, because I think what we don't understand is what digital RF is and what it is not. What digital RF is it is a method of storing the time domain raw IQ data in a file format. Okay, that is not, so it's digital RF in and of itself is not actually doing digital signal processing. It's not actually computing FFTs. All digital RF is actually doing at its core is storing raw IQ samples.
I don't understand how you're taking the analog stream of probably either 8 or a 44 kilohertz sample rate and then reducing it to a 10 hertz bandwidth. That requires processing.
Yes, so I understand that, but what I'm trying to do is yes, that is digital signal processing, but digital RF itself is not
correct.
It's
the digital processing that I don't think we can determine that. What I'm basically saying is we can determine if we can pull it off, but I do not want to put that on the plate before April 8th, because that could be a major showstopper.
Okay.
And a major amount of work to get it to work, because digital RF will not run on Raspbian, and that's what we are running on.
Okay. So
and that's another minor problem. So
right.
For April 8th, I'm just saying I do not want to derail this.
Okay.
Yeah.
So here are the reasons. So what am I looking for? I am looking for a system where we can capture this data and we can efficiently get it up to Bill Engelke's server and process it and get it all in one place. Okay. And the reason, what's that?
In DRF for that to happen probably? And if so, is there a way we can do it after the recording?
Well, so the answer to that is both right now. So right now, if you want a plug and play system, if you're going to create a system that will just plug and play without Bill having to really do any additional work on his end, then we have to provide the data in digital RF format. And then there is a way that it can get from the Grape up to his system seamlessly, and he is able to handle that. He's all set up to plot these FFTs that we can show in a few minutes, and he's able to do all that processing on his end. So
Can I make a comment?
Yes.
This is Bill. I'm on the road right now. I'll do the best I can. There's a couple of things we can do. I mean, if we want to capture all the data, this very wide bandwidth, we can save it in the raw form, just like John is preparing to do, and have an auxiliary system that extracts whatever we're going to save up at the server and uploads it in digital RF form, and just do that processing on a separate computer. That can be done.
But doing it on the fly is the problem because of the bandwidth of the channel. Because we're having a problem between the Pico and just the Raspberry Pi and one getting it in there.
Yeah. Well, here's the thing: is there are ways to deal with it. There are data processing ways of dealing with that. I've dealt with this kind of issue before, where the disk system had a limited bandwidth, and there are ways of dealing that. I can promise you. I don't want to
Okay.
go into the details of it now because it takes a while to explain. But the other thing is, right now, we need to consider the fact that the University of Alabama system, as it's configured, doesn't have anywhere near the kind of storage capacity that you're going to need to store a lot of wide bandwidth signals.
Couldn't find a gas station close.
Are you not getting my?
No,
No, we're
we
getting
got
on.
it. Yeah.
I can't pull over because
Yeah.
I'm following my wife and we're going somewhere. Anyhow, but are you able to copy?
Yes.
Yes.
So,
Okay.
so
But we got to figure out where we're going to store all this data too, and that one probably won't be an Alabama system.
So we could do it this way. One option is if we really want to make sure if we don't want to worry about the uploading to the Alabama system for the moment, we could just say, okay, we're going to just design a system that for now saves all the data to the local hard drive, and then when the experiment is over, they take that hard drive and they ship it to us, and then we can post process it later, or we can or they can just upload those raw data files to Bill for processing.
And that's exactly what we're doing now with Grape 2.
Right. So
if I might ask, John, what is the sample rate we're talking about here?
We're sampling at an 8 kilohertz on 3 channels.
That's what I thought. I still say something is really wrong here because we're doing, mega sample per second on Raspberry Pi 3s and doing multiple FFTs on it.
Understand, but you're not doing it in a time synchronous fashion. You're using the buffering of the system. Your clock is not synchronized to anything. It's running free, as well as the operating system queuing. You're not doing it consistently. It's doing it in bulks, in chunks. And that may be acceptable, but you do not have a deterministic sample rate.
But I thought, John, that so the way I thought your system was working is that you were
don't have a
doing the
deterministic sample rate.
I thought you were doing the deterministic sample rate on the Pico.
That is correct.
And then I thought you're getting a deterministic timestamp from
the Pico.
From the Pico, right?
Yeah, and then I'm shipping it up over USB to the Raspberry Pi. And that's
so what I don't understand is if you have deterministic samples, both data samples and timestamps at the Pico level, you have all that information. Once you have all of that done at the Pico level, why does it need to be deterministic after that?
It doesn't. What I'm saying is, if you're using the operating systic under digital RF, that is not to the level of what we're doing. It's good. Right. It might be good enough, but
no. But you don't do that. What you get digital RF has the capability of taking the timestamp that you have read off of the Pico and using that timestamp.
Okay, if that's the case, then it's not a problem.
Exactly.
You still have to do the conversion to digital RF to get that stream at the full 8 kilohertz. I'm saving 8 kilohertz of data, 16 bits deep for 3 channels continuously.
But so what I'm saying is I don't think that the digital RF is nearly as processor intensive as you're suggesting it is.
Well, if you're not doing any reduction, I would agree with that. It's just a file format change, and you're writing another set of files to the disk.
Mm-hmm.
And if you're not doing it on the Raspberry Pi on its disk, that means you have to transfer it off of the Raspberry Pi to do post-processing on some other system, which is another channel that's going to be fire hosing that stuff off.
Right. So I think at the end of the day, whether it happens in time for the eclipse or whether it happens in time for or it happens afterward, what I see as a system requirement is that we are able to capture as much bandwidth as we are technically capable of, and that at least that contains both the carrier and enough information to identify whether it's WWV or WVH. We need to
right now we're
that.
capturing a 4 kilohertz bandwidth with an 8 kilohertz sample rate.
Right.
on all
And-
three channels.
Right, and then we need to use the deterministic. I agree, we have to use the deterministic timestamps off of the GPS.
Which is what the data engine is doing with the 1 PPS and the synchronized clock
Right.
domain. So
And
yeah,
then-
we're doing that.
So great, so we've got that, and then from that point, we have to have an effective method of reliably transporting that data from the local nodes up to the central server.
Now, when I was doing the collection for 44 hours this past weekend for Rachel, I was noticing that it's about 432 megabytes per hour. Now, if you have a bandwidth connection on the internet that can transfer that within the hour, you could feed it
Mhm.
to a server. But again, it's 10.5 gigs of raw data per day.
Right. So I think that is possible.
And we also could probably cut that in half if we go to binary, because we're storing it as hex ASCII right now. So we went to
Right.
binary, we could knock that down to, 220.
Oh, absolutely. This data should not be transported in ASCII.
Well, like I say, we're getting the system just to the point where we can actually test it. So
Okay.
we're getting there.
And I mean, really, even on a system level, my personal belief and understanding of these systems is the data should really never be stored. This data should not be stored at ASCII at any point in the system. It
Well,
should
that's the way it's
always,
coming out of the A to Ds.
okay,
It's
but
actually coming out as a binary integer. And the way we're storing it is up to us. But Bill
Right.
Blackwell can shine a little more light on that. But we
But-
have the option of switching it to binary. We have not tried that yet because we're
Yeah.
still trying to get the system to work consistently.
right.
We're not
But
quite to the
I
point
think-
where we can
I
start
don't, I
playing
don't
with these.
understand your comment switching it to binary. It comes out binary.
But we're transferring it and saving it as hex ASCII
Right, and that's what I'm
Where?
saying.
Where
I
does it
don't-
get converted
think-
to ASCII?
in the Pico. That's
Why?
a USB data channel. That's the way we set it up for doing debug. And that's the worst case scenario. We can go back to, we haven't tried the binary path yet.
Yeah.
Because we're not quite ready to try that yet. We have the surrounding infrastructure of what the code we have written now isn't quite ready for transferring to that, but it's in the system to be able to do that.
I'm still not understanding your statement about deterministic sample rate. We're listening to deterministic sample rate right now on Zoom. You're talking telecom data rates.
No, it's not. No, it's not. It's coming over a non-deterministic path. Ethernet comes in blocks. And it has retries.
Pardon
And
my
It's
it's
ignorance.
isochronous. You can't listen to it if it's not isochronous.
But it doesn't,
Definitely, the clock is not synchronized. It's
But-
running off crystal. It's
but
not
that
synchronized.
doesn't, but we've already established that doesn't matter because we've already established that you are getting you're getting synchronous timestamps and data at the Pico level.
Right.
So you have that
So that
information.
problem is solved.
So-
Yes.
Right. So I'm not worried about that at all. But I do know that if you do have the data coming across, the data is being stored as it's binary integers right now.
Right now, it's being stored as hex ASCII.
It's being stored as hex ASCII, but there's a conversion from binary integer to hex ASCII.
We flip one little software switch in the setup for the Pico, and it stores it as binary.
Okay, but
It's
that
already in place.
right there, that should be a tremendous decrease in the amount of memory space that's required,
It'll cut it in half.
at least. And then, so
And we
I
have not
think-
tried compression yet either. So I mean, there's all kinds of things you can do. But my
right,
problem is the deadline. I have to have this system working consistently and reliably before April 8th. I can't have any hiccups. And
I
that
understand.
does not allow me to try all these exterior things until we get a baseline system that is consistent and the boards are working. We're
Right,
just
I-
getting to that point now,
right. I understand that.
but I
And-
am 4 months behind schedule.
Okay, I understand that. So here, John, I think it's very important to have, we're very much on track to having something that at the very least, if nothing else, it sounds like you're on track to have something that can dump the raw data to the hard drive,
Yes,
and then at that point we can get it. We can have people ship the hard drives to us, and then we can reprocess the data.
exactly.
Are you comfortable with at least that plan right now?
Yes, because I've actually demonstrated that over last weekend. I had it running for 44 hours. I had it actively on an antenna receiving WWP 5, 10, and 15 megahertz simultaneously. And I've got a drive sitting right here for Rachel that has 44 hours of data on it.
Okay. I think that, so that is our, contingency plan.
That's the baseline system as far as I'm concerned.
Right.
And once we get that working reliably, and position that stake in the ground, then we branch out into all these other possibilities. And I really do see us doing some kind of processing or reformatting after April 8th to do the digital RF.
Okay.
But
So,
I'm just not throwing that big wild card in the mix yet.
okay.
Because I want to get a working system out the door.
All right. That's very understandable. So in that case, our understanding is that your goal right now is just to have a complete system that is going to dump the data to a hard drive, the raw data to a hard drive. And at the very least, we're going to be able to ship those hard drives back to us for processing later.
Right. In addition to that, it will also be sending out the pulse per second data to the WWV ARC repo for the 3 channels.
Okay. That sounds good.
That's what David Caston is going to take the 1 second epoch of data and give me 6 numbers, which are 3 peaks and 3 frequencies. And that gets stored once per second to the file in the same format that it's doing it now on Grape 1.
Okay. Well, all right, let's go ahead and build that system.
That's what the track I've been,
which is what you're trying to do.
on.
But then let's also have the understanding that as soon as that system is tested and reliable, we're then going to go ahead and start evaluating how do we do this next step of
Right.
getting
And
the
that
data.
could be a software push. If we play our games right, and I've been thinking about this, if we had the Grape 2 systems tied into a GitHub repo, pushing out a update is simply a git pull.
Okay.
That might be the way to do it.
Yeah. I think for this, since we're still just going to be sending out, I think for this probably, well, we could see how that works, but my guess is it's probably going to be easier or better to post an SD card image or actually mail out SD cards to people, at least at the beginning.
For the Grapes?
For the Grape 2s.
Grape 2 is going to be a completely built system. Because of the way the hardware integrates and the way it tests, the whole thing has to be built as one piece. So these are not assembled by users.
No, I understand that, but the software, still there's going to be a Raspberry Pi that has an SD card in it, right?
Yeah, and that's integrally tied into the Grape 2 with a 40-pin ribbon cable. They can't run without each other. Right,
but they can open the thing up and they can replace the SD card if needed, right?
True.
Yeah,
that's true.
So my thought is, right. So one path forward is that once you get these things built and deployed, we can probably
that's the key comment right there, built and deployed.
Okay. So
once we get them out there, then we can start playing games.
Boy,
okay. And then we could have a situation where we have either the Alabama team or your team or Kung or someone after those are built and deployed, we can then have someone work up a new SD card that has these new features that does the processing and we can test it. And then we could potentially post a new SD card image online or mail all of our deployed systems new SD cards. They take the old chip out and they replace it with a new SD card.
Well, the thing to do with that would be, well, if you're changing the operating system, that would make sense. If you're not, I think the GitHub thing is a better way to go because that way they're all in sync, everybody's the same, and we control the updates.
But both are options.
Yes, and we will look into that once we get to that point.
Okay.
And I fully support that, and that's the ultimate goal, but the immediate goal does not include that.
Okay.
Because I have to get, we can get the data and save it, then we're good. But if we miss the data, we're screwed.
Yeah, no, I agree with that.
And that's my focus, is to get the systems deployed so I can capture at least the raw data.
Yes.
And that's the track I'm on. And I demonstrated last weekend that the system does capture it and save it consistently without error.
That's very good.
So that was a major hurdle this weekend.
Yes.
We're still fighting with, implementation issues and stuff like that, but we're getting pretty close. I'm very happy with the progress we've made. Bill Blackwell and Kung have done some amazing things that I certainly could not have done. Bill's experience has come shining through. We were having segment faults that he spotted right away and fixed due to his experience of doing this firmware type coding in his previous job. So that has paid off in spades. So we're in a really good place, I feel, on the software, or the firmware, I should say.
Okay. I think that sounds really good, John.
And going with the Leo Bodnar for the RF source has lifted a major burden off of me, and I'm probably going to use the existing U-blocks since we have them, and it's zero cost to use them for the GPS unit. And then the Grape 2 version 1.2.1 will have a GPS module that costs, I think it's either $18 or $11 instead of 130.
Okay. So
And
is that, when you said you're using the U blocks, are those the ones that you had purchased that you thought you weren't going to use?
Those are the ones that I purchased that we were having the problems with, but we're not using the secondary frequency out. We're using a Leo Bo now to replace it.
Okay.
But it makes no sense to change those out because we have them.
Okay, great.
Use them. The board's laid out. It's working with it. I don't want to change it.
Okay.
It's
So-
too risky.
Right. So those are things that you had previously said you might not be using, but now you will be using.
I will be using them because it doesn't make sense to change them out at this point.
Okay, that sounds great. That actually is bureaucratically easier for me.
Yes, I kind of figured that.
So that sounds like good news to me.
You
Do
know
other-
that under Clementine, John's working on what they call the Glen GPS DO.
Right. I evaluated that and I gave a report on that last week.
Well, it's
Spurs,
improving rapidly, apparently.
yeah, but the board I got was a build that John Ackerman had just done 2 weeks prior. And the firmware was given to me last week. And as a stake in the ground at that point last week, the Spurs were way, way too big for us, for our method of determining frequency. So that's why I abandoned it now. We may both go back to it if it proves to be useful, but as it stands now, it's not usable for our option, for our frequency, RF frequency source. It's got too many blips on it.
Yeah, well, stay tuned. And
Yeah,
we're
oh
trying
yeah,
to work
definitely.
out a pulse per second out of it.
Yeah. No, I think this I think everything makes sense here.
Yeah, we're great. This is a work in progress and it's never really going to be finished, but I have to limit the scope of what we do to get the release so I can build it.
Yeah.
That's what I'm doing now is I'm saying, yeah, we could look at, but I'm keeping my blinders on to get to the point where we have something in-house. We got it distributed. We have them in place working. Then we can start looking at other options to put on if we feel it's not too risky and not break the system before April 8th. But after April 8th, it's, we can completely redo things.
Yeah. I think that makes sense, John. And I think, and I do support your path forward here.
I sorry if I made it sound bad, but it's just, I'm very, very trying to keep a very narrow focus because at this point, it's very easy to diverge and look at this and look at that. And before you know it, April 8th is here.
Yeah. I completely
wanted
agree
to
with
have the hardware design done by the end of August.
Yes.
Just getting to the point now where I feel comfortable. I'm doing the last turn on the digital card, the controller with the Leo Bodnar as the input and driving its antenna off of the one that's on the U blocks.
Yeah.
Once I release that, then I get those boards built. And once we get them together, then we can start assembling a system.
Yes.
So,
I think that sounds very good.
but I've got to stay focused because if I get derailed on this, I don't have the time. I have and the bandwidth. I think it's too close.
Right. No, that's very, I appreciate that. Yes.
Yeah.
We can't ask for an extension on April 8th. I don't have those kinds of connections.
Yeah.
Only one last question for me, and that is any update on the magnetometer situation?
There was a board sent out by Bill Witten and Hyman
Gilman.
that they're doing a public release of the board. We're going to review it. In fact, he sent me the board and I haven't had a chance to look at it yet. He does have a separate remote and local boards. So that in and of itself means we can just build the remote boards. But I have to make sure it has a temp sensor on it. I'm pretty sure it does, but I haven't had a chance to look at it because, like I say, the remote board, Scotty had a temperature sensor on the remote board, and then at some point in time, they determined they didn't want it, but I kept it on there because I'm measuring the temperature of the frequency standard, because this will tell if things are wandering, and it's a very useful piece of information to have. But that's all built in and working. I'm still fighting with trying to get the remote board to talk to me, but like I said, I haven't had any bandwidth on that because I've been focusing on getting the digital RF, the RF decks built. Once I get those in processing going, then I get back to it. But there's only so much of me, and I'm still working full time here in the lab. Just calibrated 20 DMMs yesterday and the day before yesterday, so I've been kind of busy.
Okay.
Yeah, that
Anyway,
makes sense.
back to Rachel.
I can also give somewhat of an update. I know that Hyomin and Dave Witten met this week to review those designs, and Hyomin's working on writing that into a hardware X paper. So they are making progress on this.
Cool.
And Dave Witten did send me some Python code to actually diagnose talking to each board individually. And like I say, I haven't had a chance to fire it up. So when I do, I'll have some progress. Hopefully by next week, but we'll see. But like I say, my focus right now is trying to get the first set of boards built. And I haven't, like I said, I've got 3 bids sitting in my mailbox that came in yesterday that I haven't been able to look at yet. So I don't know where we are on that, but I'm hopeful that we should be able to move forward on this quickly.
Okay. Thank you, John, as always, for all of the hard work. I'm happy with the idea of getting a hardware system out. Kung, did you have any software updates that you wanted to talk about?
Yes. Yeah, and I agree with John. Shout out to Bill for helping. So what happened was we got some code for the frequency analysis software. We got some code from David Kasdan, and I tried to integrate that with the rest of the system, but unfortunately I ran into some issue that I couldn't fix. So I had to scream for help, and Bill Blackwell descended from heaven with his magic staff and solved everything.
I like that.
Yes, that's a very good analogy, Kun.
And everything works perfectly now.
Not magic for you, Bill, but it's magic for us. So yeah, your talents are greatly appreciated.
Turning red.
Desperately needed.
Thank
Yeah.
you.
And I'm currently writing the checksum generator so that we can verify that the data came through correctly. I'm running into some minor issues, but I should be able to solve them on my own.
One of the things I am doing is determining and trying to break the data transfer portion of the system to see how much headroom we've got. We've run it at 10 kilosamples, or Bill has run it at 10 kilosamples per second per channel, and it didn't break, but I'm going to be trying to push that to see where it collapses. Does it collapse at 12? Does it collapse at 15? How high can we take it? Because the USB utilization, I put it on Logic Analyzer, is pretty full at the 8 kilohertz. So I'm not expecting to be able to go too much farther than that, but we'll stay tuned. Back to you, Rachel.
Okay. Yeah, is Kasdan on? Because I was gonna ask, does that mean this code is completed, or is this still in like a testing phase?
It's still in
always in testing. So story is does accept the data vector. It gives back at least some answer. It's not an excellent answer at this point. It needs work, but there is code to check and see if it runs fast enough that the data can be processed with the available time each second. And I appreciate Bill's help.
Okay.
Yeah,
All
2
right.
nanosecond overhead. Basically, we were somehow the array per second was getting pushed onto the stack and causing a stack overflow, which then caused a segmentation fault in the operating system. It kind of gets your attention.
Yeah.
But Bill spotted it, figured it out. So it was like, whew.
Okay. Any other updates on the Grape 2?
My toes are starting to turn blue.
I'm working on the case where the pulse per second drops out due to a GPS losing lock, and handling that, recovering and handling it gracefully, and that seems to be working. That fix seems to be working. So GPS can go in and out, and the Pico doesn't die. So just testing that, finishing testing up that now.
And those are the kind of things you don't think of until they hit you, and then the system crashes. So
yeah,
kudos to Bill for recognizing that one. But that is the Achilles heel of the Grape 2. If you lose satellite lock, you stop data collection because you have no frame or time reference. Unless we can get the GPS to go into a carryover mode, and I don't know of any modules that will do that we can afford.
Right. So at the moment, if it loses GPS lock, it stops collecting.
It stops data collection. Yes.
Okay. So a nice on the plus side to that, it helps you to guarantee that you're getting good data.
right.
Yeah.
So
And it only needs
actually,
one satellite fix to keep going.
okay.
You need 3 for a 3D fix. But I think the module I'm looking at to replace this, the Adafruit one, actually gives you a hardware bit out saying it has a 3D fix. And I haven't pursued seeing if there's any kind of carryover mode. I haven't seen one on any of the GPS modules yet, but I haven't had a lot of time to research that. But there is a real-time clock, I know, in the U blocks that you can battery back up, but I don't know if you can have it generate the 1 PPS or not. It seems like it should be able to, but I haven't been able to figure that out yet. I haven't really dug into it. Work to be done.
There's also a real-time clock on the Pico that we're not using, but that's not battery back.
Oh, okay. Again, future work.
Yeah.
That's a
not
major plumbing
synchronizing.
change to switch over for the 1 PPS. And the hardware right now, we'd have to somehow disable the output drive of the GPS module itself to be able to drive the 1 PPS. So right now, the hardware will not handle that. So unless you did it from a firmware, you're not looking at that. But the 1 PPS is what generates the reload of all the registers and the resyncing of the engine. So like I say, there's some serious work to be done there and considerations that have to be designed in to be able to do a carryover. It was not in the original idea.
Yeah. That makes sense.
Any other comments on Grape 2 stuff? All right.
Once I'm 10 minutes over, I'll keep my mouth shut.
No, it's okay. No, this is all really important stuff, and this is our new deployment priority. And just our timeline just cycles
No.
All right. Let's see. Let's start with the Grape Eclipse data, just because we're running short on time now. It would be, since we didn't get a lot of time to look at actual data this week, and Dr. Frizzell wanted to, I'd also like to encourage everyone, if you ran a Grape for the eclipse to keep running the Grape for as long as you are able. And if you aren't able to keep running one of the NSF funded grants, the NSF funded groups, it might be nice if we could like put that in a different location. If you can't keep it running anymore. All right, Dr.
Probably should be done by somebody looking at what's getting uploaded every day, probably through Bill Engelke, and figure out what stations are stopped and then pursue as to why, and if they're not going to run them, get them back.
Yeah, and Gary did point that
Yeah.
out. Oh, here we go. Last week.
Yeah.
As
Yeah, why don't we take a minute to talk about this? Because I think this is actually a really important point. The Grape project, you know, we've really rallied around the eclipses as our own self-motivating deadlines, as John has kindly pointed out. NASA, because of NASA's bureaucratic process, we're not able to request, you know, postponement of the eclipses. So we have to go with those deadlines.
You don't have connections either, huh?
No, I've tried.
But you're at the right school to do that.
You know,
Come on.
we've got what we've got. You know, some things you just can't, are just out of our power. But
You're pushing on a rope.
but so we have, if you look at our grant and our scientific objectives, they're actually much bigger than just the eclipses. You know, we're trying to look at short-term variability in the ionosphere. So we're interested in these traveling ionospheric disturbances that occur every night, every day. We are very interested in what's happening at dawn and dusk. We've got this propagation mode splitting, where you have one ray hop going off the F layer, another one going off the E layer. You have another one that's going 2 hops off the F layer. You can see all of these features in our Grape data. And we really want to get the message out to people that, you know, their data, we want them to run these things all of the time and for as long as they possibly can. And I think maybe Gary, since you have been our big evangelist to try to get the word out, do you have some thoughts onto how we can encourage people to keep the lights on?
Well, the most response I've gotten from the stations were sent out were the couple of images we showed on in this meeting a couple of weeks ago, and people saw how their data was being used and what it displayed. They were pretty excited. So so that's, I guess that's what we need to get out there, is just a few of those things, and these 4 points we made here about the different type of phenomena we can identify and want to study. I think those would go a long way.
Yeah, I agree. That's the key thing, is getting some data out there for people to see and say, hey, I contributed to that.
I think the visualization is key.
Yes.
So I think
Absolutely.
yeah.
Yeah, we
So
have something working on that, and then we're within the next week or two, we're going to roll it out, so everybody will be able to see every plot.
Oh, cool. Double
right
his
now
salary.
we have software running that automatically plots every upload, but we're going to add it to the observations page, so that when you call up that observation, you'll see the plot, and you'll also have a button where you can download a JPEG of the plot if you want to use a nice clean JPEG or PNG of it.
Will there be a way to request your data specifically?
Yeah, everybody can request any data from anybody, including themselves.
Ah, fantastic.
That's been working. That's been working for months.
Oh, okay.
Yeah, the filters work real well.
Well, ship it.
So maybe Gary, would it be beneficial if I wrote an email myself to the Hamside Grape listserv, encouraging people to keep the lights on?
That would help, and I would then copy that, and I'll resend it to especially the 26 or so stations from the so-called Cedar grant list. And the other thing I want to encourage people too is, a lot of hams may not understand. It's like, okay, the eclipse is over. Where's all the scientific analysis? They don't realize, as you stated pretty eloquently a few weeks ago, it sometimes takes years to get this stuff through the peer review process. So we've got some short-term results. The long-term is really a multi-year process.
Right. And I can tell you that once the results do get published, they are used in the long term, which is, people keep, I reference papers that are 50 to 75 years old all the time, actually. So once you actually do get it through that long process, it's a very meaningful thing. Okay,
yeah. So I guess what
will-
I'm saying is there's a short-term message saying we've got your data, it's providing useful stuff and interesting stuff. The long term, this is how we'll use it. I think if we glue those two things together, that'll help.
Okay,
And that you can see your data from yesterday on the control panel site.
Yes.
Yeah, right.
Which
Yeah,
should
that's
be
the quickest short-term thing we can do is visualize what you've uploaded. And I think that'll satisfy probably 95% of the people out there. Oh, there's my data. They must be using it.
Yeah.
Agreed,
So
agreed.
I think what I'll do is Bill Engelke has already sent me and us the plots of all of the data that we got from Eclipse Day. And I'm going to show them here now, and I'm also going to put the link in the chat. And I think I'll include this link in the email that I send. And then I'll explain what we saw, and I'll also tell people that within that the Alabama team does have an update in process for the website that will let people see their plots on a daily basis, and anyone's plots on a daily basis. And that will hopefully help keep people's interest.
Right. However, if they can't or won't keep the lights on, we want the systems back, the ones that we sent them.
Well,
So what I'll do is, go ahead, Nathaniel.
Oh, I was going to say, I agree with that. And one of the things we could do is we can, after a few weeks, we can start monitoring. I can include this in the email too, that we are monitoring when the markers go red and when they go green. And then, I don't have to say this right away in the email, but we can watch that over the next few weeks. If we see one that we deployed that's not lighting up green, we can reach out to them and be like, hey, we noticed your system's down. Do you need some help? We don't need to threaten to take it back right away. We can instead be like, hey, we noticed your system's down. Do you need some help getting it back up? Or, kind of what's going on. We care. So there
are 2 or 3 stations that are already in that situation. I watch it every day. And then 2 or 3 stations have gone either yellow or red. So there are a few that have reasons.
Yeah. So
I don't think I would wait 2 weeks to do that. I'd start that now.
Yeah, so I think that makes sense, but I think the message should be, instead of we're going to take your grape away from you, I think the message should be first, hey, we noticed your station's down. Do you need help getting it back up?
Right.
Something like
I
that.
also move the grape if they really don't want the grape anymore and if there's a reason they don't want to maintain it, like they're moving, just happens, then I feel like it's worth moving the grape if they're up for that.
Yeah.
But I feel like most of them probably aren't in that boat.
Yeah. And
we have to offer some technical assistance, because I know the one station out on the West Coast, Alpha Delta 6 Oscar, his station has never worked. It's only ever outputting noise. So he's not, I've emailed him about it, and he, for whatever set of reasons, has not been able to address whatever it is causing his station. It's nothing but noise. That's just what I've looked at.
Nathaniel, I would address, construct that email as something like, we've had the eclipse, now what? And basically say, are you planning on keeping your grape going, or are you planning on shutting it down? And then basically have 2 sections to the email, and then for everyone explain this process of, here's what data, here's where the data has gone, here's what's going to happen to it now, and be prepared for a long process. It consists of the basic steps, just since most of us have little experience in that.
And this is
at least at the very least, we want them to have the system up and running for the next eclipse.
Yeah, why is it important?
This is not just about the eclipse.
Yeah.
This Just as
I-
not
I
just
think-
an update,
Certainly,
but
but that, you know,
I'll work on that. I'll work on crafting that email over the next day or so, and maybe I'll run it by a few people before I do a mass mailing. But I think I can effectively get those ideas into an email.
thank you.
Yeah. So while we're talking about this, I do want to take a moment. One of the things that I think we didn't do last week that I think we should have is actually look at the data that we got from the eclipse, because I think it's really beautiful. So
Yeah.
Rachel, if you don't mind, I'm going to take over screen sharing here for a second.
Absolutely.
All right, let me just make sure that I have. Okay. Gonna share screen too, so everyone can see the nice Firewatch background there.
Mhm.
That's your backyard?
And actually, my backyard's not totally dissimilar.
Cool. What a
Yeah,
playhouse.
you sent me that picture of your friend this morning out on the track at Case Western.
Yeah.
I frequently see, anywhere from 10 to 20 of them in my backyard.
Well, being that we're in an urban wasteland, having a deer in the middle of the athletic field this morning was like, uh-oh.
Yeah, it's
Yeah.
like, uh-oh. But yeah, so we got Bill Engelke's automated system. He is able to generate these summary plots for every grape that uploads data to the system. And so the day after the eclipse, he sent me 33 of these, and I put the link in the chat so you can get all of these yourself too. And this is Bill's station AB4EJ, and on the top we have a spectrogram. It's 24 hours. You can see the red here is an attempt to kind of recreate what the Grape 1 is doing with the just picking off the maximum frequency. I would say ignore it for now. I think David Kasdan's working on his algorithm, but just know that that's why that red is there. And those red points pick off the frequency with the maximum power at each time step. And then the amplitude at that minute is plotted down below. And so in all of these, you can see there's a period where you have negative Doppler shift, that's dusk. You have positive Doppler shift, that's dawn. And then somewhere between 16 and 18 UT, you can see again negative Doppler shifts and then positive Doppler shifts. And that's the eclipse right there. So there. Here you can see it. This is my station in Pennsylvania. This is Grape. Who has Grape 32? This is Grape 32.
Yeah, that's mine.
Okay, Todd. So yeah, there's your eclipse observation right there. It's very nice. Here's a Stan KD1LE. We can see the eclipse there in Massachusetts. Here, this is John. You're node 11, right, John?
Correct.
Yeah. So N8 OBJ, you can see it there. Here's George, KB1 HFT, right there. Here's N4TBC. Who's N4TBC?
That's me.
That's you. Who's me? Charlie?
Charles? Yep.
Hi, Charles. Yep, there's your eclipse. We can see it right there. It's beautiful. And actually we have two from you. So are you running two stations?
I was running one in the Ohio Valley and
Okay.
running one in Northern Virginia.
Okay, great. So one of them, this second one, where EM57TA.
Yes, that's the Ohio Valley.
Okay, the Ohio Valley one, you have a really, really nice signature there.
Great.
And
That station was only up for the eclipse. And it was personally provided, and I'm going to bring it back up for the total eclipse, but I'm not at that location all the time.
that's completely fine.
Can you leave it running in the background?
Here's KC4LE.
Well, I could, but it would be no way to restart it if it crashed.
Here's
Probably
KC.
taking the risk.
Yeah. Here's KC4LE.
Well, we need some headless capability on these things to do things like that.
Yep.
Yeah, well, that will come. I think that's similar to what John was saying. He's like, we need to just get this Grape 2 to collect the data, write it to a hard drive first, and then those things will come.
Understood. Thank you.
Yeah.
Whoa, what was that?
Yeah. So this is KI7DLN, and yeah, this one's really wild. So
Where is he? Or she?
Seattle,
Yeah.
Washington.
Nice.
yeah. So yeah, you have a great eclipse signature here. I don't know what was
Oh,
going
oh,
on.
wait, or maybe that's sunrise in Washington.
Maybe you have the eclipse and sunrise.
No,
Well, it
no.
sunrises later out there than it does in Massachusetts.
Yeah.
Not that much.
Yeah, the eclipse was near sunrise. I don't know if they coincided.
Yeah.
No. As someone who lives in Seattle, I can tell you they did not coincide.
Thank you.
I witnessed it.
It was about an hour and a half between the two. Sun rose around probably 7:30.
Yeah.
It's interesting because I have a Grape 1, the other kind that uses FL Digi, and I have a very similar pattern to that for my FL Digi. It's like really wild.
You should. I mean, you should see there absolutely should be a correspondence between the FL Digi and this, and if there's not, there's a problem. So
But
really
I was kind of interested in this because now you have observation stations that are either on the path of the eclipse or the eclipse goes between them and WWV.
Yeah.
Now, I'd be a little concerned about the carrier shifts, the Brough shifts in this data.
Yes, I completely agree. I do not know what's going on here.
I don't know. Unfortunately, we don't get data from the Bodnar as to what it's got for lock.
Yeah.
But
But yeah,
one of the problems I have with Bodnar is that you don't know when it falls out of lock. And being a TCXO, it can jump.
So there's definitely issues with this. But that I would bet that is the eclipse signature there.
Mm-hmm.
Over here is KE9SA. There's the eclipse signature. Here's AB1XB. There's Bill Blackwell. I can see it there. And I also want to point out, you know, some of these look very faint, but that's, you know, the way we're plotting it right now. These are just summary plots. Let me just go back. So this is AB1XB. Let me just go back to my station for a minute here. Where's my, yeah, right here. Okay, so this is a summary plot from my station. And let me show you what the real time this is what the real time display looked like. So this is a real time display of my station. That's the summary plot. So it's the same data, it's just being visualized differently. So here you can see the signature much more clearly than you can over here. So even if the signature looks kind of poor right now in what I'm showing you on your summary plot, the data is there. We will be able to pull out that signature and get good information from it. So it's just.
But that previous one you had, there was a lot of stuff that was roofing at 3.5 hertz. If you go back to the one plot that we're.
This one?
No, the previous one,
This one.
No, go back to
the one that was weird at sunrise.
Yeah, the lower one there. Yeah, see how it has a bunch of stuff at 3.5 hertz from 1600 to 2000. The red line on top there.
Yeah.
That tells me there's something going on with a lock.
Yes. Yeah. So I agree with that too. There are still issues here, but even with those issues, I think that if you cut and you just look at this little part, I think we're going to be able to get very useful eclipse observations just from looking at this.
Yep.
So
when the Bodnar loses lock, does the light start blinking?
Yes.
Yes.
Okay, thank you.
So
and I've seen just recently a Wagner on a lock, and I solved the problem by moving the antenna, but
Here,
but I
Ward,
believe there's a signal that is detectable if you look for it. Bill Blackwell and I were talking about this the other day. Bill, are you still on?
Yes. You can query the Bodnar, just run the LB stat command and get the GPS locked flag, and you could somehow coordinate that in the data and show that you're either locked or not locked. We have to figure out how to do that.
Is that something we want to consider for the Grape 2 architecture of bringing Leo Bodnar into one of the USB ports on the Pi so we can do that?
Yes.
Because that will fill up all
It
four
is.
ports.
It is.
Yeah, you can just query it since it's connected by USB
Okay.
to the Pi. But of course, we're using up one USB slot to do that. But,
Yep. Well, the Grape thinking is intended to be run headless.
Speaking of USB, is there an argument against using a hub to transfer to connect USB hard drive and USB sound card to the Pi?
That's my system is set up that way. I have most of my stuff plugged into a powered USB hub, and that solved some issues I was having with the system crashing. I had enough stuff plugged in; it pulled too much power somehow, because I use wired keyboard and mouse and etc. So powered USB hub solved that problem.
But does it affect the data collected or the timing or anything?
Well, you don't put the USB hard drive or the Pico line on the Grape 2 on the hub. They have to go straight into the Raspberry Pi. Now, the design criteria that I'm working with is I'm trying to make the Grape 2 entirely run off of 12 volts. Because I got a regulated 12 volt supply that's going to run the 4 terabyte hard drive case. So that will be running off the battery or that power supply or 12 volts. And I'm also going to be running the Leo Bodnar off of that same thing, because the 12 volt, my 5 volt switch mode power supply on the Grape 2 can supply up to 6 amps. So I have enough power bandwidth to be able to handle that. But I want to make it such that you put it on a 12 volt battery and you forget about it.
We're growing short on time here. You have a few more
we're
things
negative
to
time
show.
now.
Yeah, this is all really good discussion, but yeah, I think Ward, this is your station, right? W0ECC. Yep, so that looks good. And there's WA9TKK. So this part over here looks great. I'm not sure what's going on over here, but this part looks great. Here's another good one. Here's St. George, AA6BD, very, very nice. KD60 needs some technical assistance, I think.
Yeah.
Yeah. N2IC, this looks really good. KK2Z-L, this looks excellent.
Where is that?
EM00WV. I'm not sure.
I don't have the chart in front of me.
Yeah, we'll have to KK4HP.
Look at that on the power down there.
Yeah.
Right at Eclipse.
Here's Joe W7LUX. Looks great, Joe, over here.
One thing I noticed is that if you have a lot of signal input from a good antenna, you get a lot more detail on these particular displays, these particular graphs.
Mm-hmm.
Yeah. Here's VE3GTC. I think you see it over here. K4BSC, there's Jim's. Very nice. Here's N95F. You can see it. There it is. I can see it on my screen. AD0RR doesn't look like, it looks like WWV dropped out during the eclipse there.
He's 5 megahertz.
Yeah, that's my 5 megahertz DRF station.
I actually can see a little bit here. So I think you could bring it out if you needed to. And this is from the Netherlands, PA0RWT. So I think the short message here is that we got some really nice data from this eclipse. It'll keep Rachel busy.
Yes.
And I think there's absolutely stuff that we can work with here in terms of the eclipse. There's also, I think we've already seen that these plots also bring up a lot of engineering issues. And something that we need to talk about that I think we ran out of time today is we see these periodic drop-offs in amplitude. Or they're not periodic, but we've got these abrupt drop-offs in amplitude, and I don't think they're geophysical. We aren't sure what's causing them yet. There's one where it's okay, yeah, this one, it's like, why does it drop
Come
off, come
back.
back?
Yeah.
So there are some issues here. So
That's got
I
the
think
fingerprint of a threshold issue for some type of calculation.
Yeah, actually, that did occur to me. I looked at the signal processing of the DRF, and it looks like this happens before we store the DRF because it's in the DRF data. I want to get Tom McDermott, who helped design the GNU radio flow graph that runs this thing, and go over with a fine-tooth comb and see if we can find.
Because this particular data set would be the perfect one to test with.
Mm-hmm.
Because it's dropping in and out, and that would give you something to work with.
Yeah.
So put a push pin in on that data set.
Yes. And for TVC, thank you.
That is that's the October 14th, and that was not going anywhere. But I need to get Tom to look at this and see if he can find some place in the GNU radio flow graph where there's some possibility of dropping off the most significant digit of a number somewhere or something like that.
Yeah. That's what it looks like.
So
Nathaniel, if you were to include these or wait until these are available in the control center before you send out your letter to the multitudes, that would be sort of an enticement and say, here's real
what
data
I'm going,
right here.
I want to send a letter out very soon, and I want to say, like, hey, thank you everyone for participating in the eclipse. And look, here's your observations, and just provide this link so I can give the OneDrive share link so everyone can see the data that's been submitted right now. I'll talk a little bit about what we see in it, and then I'll also say, by the way, like, keep things going, and I'll let them know that in the next couple of weeks you're going to see the ability to see these plots on the website on a daily basis. So I'll send that email out now. This will just be the email I'm going to send out now is just going to be very encouraging, and this is what we see. And then when Bill, and then the next few weeks when Bill has the system up and running that you can actually go see on the website, we'll have Bill send out another email, be like, hey, look, this is now available on the website. So we'll do a series of these emails. It won't just be one and done. Great. And we'll let them. And the other thing that just came out in this, I just got this email as we were on the Telecon. EOS, which is AGU's kind of magazine flashy news site, they just posted this article. Ham radio crowdsourced ionospheric science during the eclipse, and they've got some images there, and they include that image and some more composites, and there I am, and with the Grape data.
Famous. Wow.
Famous. Yeah. And yeah, so actually Christina actually sent this in. So she saw the plot. My mom got credit too for taking the photo.
Oh, that's cool.
Yeah. So here I'll put this, and if you look on the bottom, the case people might recognize this photo.
Oh yeah.
Yeah. So there's the
well, that's an old picture.
Yeah, it's funny, our current club members won't recognize that. The station's all different.
Before I built the new system.
Yeah, so I'll put this link in the chat. So yeah, I'll work on sending out an email over the next day or so, letting people, being very encouraging and letting people know that yes, we're actually using your data. Here it is. It's looking great. I'll try to give them some sort of expectations of what the scientific process is, and I'm also going to encourage people, we do have the formal kind of funded people to work on this data. Of course, Rachel is our PhD student. She's analyzing this. We are in the process of hiring a postdoc over at NJIT who's going to be looking at the solar eclipse QSO party data. I've got my students looking at things. And, most of these discussions so far on these telecons have been engineering related discussions, but I want to encourage people to also go ahead, download the data themselves, try to work up their own analysis and, share it at the HamSci workshop. So we want to try to get people to feel like they are also able to try to work with the data themselves.
Hey, Nathaniel, is my node not being uploaded? Was that a complete set of 10 megahertz that you showed?
Are you RF?
Are you using digital RF?
No, I'm using FLDG. That's the answer.
So actually, and that might be nice too. I don't know, maybe if Christina or you, Rachel, can come up with a folder of plots of the FLDigi data. And if you do, we can include that in the email also.
Okay.
Yeah.
There's presumptive stuff on that already, but I'll dig through my email.
Okay. Yeah, I am completely sunk under emails. I'm like, it's a bit of a anyway. But yeah. So I think I'll turn it back over to Rachel, but I think we should keep talking about those drop-offs there. I think we've made a lot of great progress today. I'm really happy with the plots that we've gotten. And John, I think you're right on target, and I think you are doing the right thing, just trying to make sure that all these little details are hammered out and that we get the raw data. I think that's really good. So I just don't let the deer eat your grapes. So
he chased me across the field trying to get him.
People don't people are probably wondering what in the world I'm talking about because it's a bit of an inside joke. So I should probably John sent this photograph out this morning.
That building, the white building, is Glennon, which is where I work. That's our in fact, if you can see our radio station towers on top of the building there. But there was a deer in the middle of the soccer field this morning.
They were grazing quad a few weeks ago during school hours. They are not afraid of people.
Yeah.
I will say though, we are 12 minutes past, so I'm going to say that anything that isn't urgent should probably be saved for next week. Sorry, Gary, on the website updates. This is the second week we've pushed that back, so I'll try to cover it a little earlier next week. And then we'll follow up on maybe the amplitude drop-off issues as well next week. Okay, anything urgent? So if not, I'm going to call a close and run to class.
Thank you.
All right. 73. Thank you, everyone.
73. Thank you.
Thank you, everyone.
73.